Today we're looking at lesson 3.3 for geometry, which is on slopes of lines. Last year we did slopes with algebra. This year the definition of a slope doesn't change, but we're going to be doing a few different things a little bit more complicated than we did last year with slope. But just to review, you have technically 4 different types of slope. You would have a positive slope going from left to right up, a negative slope going from left to right down, a zero slope, which is a horizontal line, and an undefined slope, which is a vertical line. And we're going to look at the numbers that go behind each one of those types of slopes in the next couple of examples. So this first example, we need to find the slope of the line containing 6, -2, and -3, -5. So we're going to use our slope formula, which tells us to subtract the y coordinates over subtract the x coordinates. So if we've plugged that in, we would have the y coordinates, -2 minus -5, over the x coordinates, 6 minus -3. So those are both minus negative, so -2 plus 5 would give you +3, and 6 plus 3 would give you +9. We can simplify that to 1/3. So our slope would be 1/3. On the next line, again we're using our slope formula, so subtract the y's over subtract the x's. This gives you -1 over 14, and we can't simplify that anymore, so that's our answer. And then the next one we have, again, all of these are finding the slope, so subtract the y's over the x's. This will give you 5 over 0. Whenever you have something over 0, we call this undefined. So this is an undefined slope. And then we have the last one, subtract the y's over the x's is going to give us 0 over -7, or if we simplify that, that is going to give us 0 as our slope. The next problem, we're going to do a few parts to it, and this has us looking at slope on the graph and also slope as a rate. We also call slope the rate of change. So slope usually has a constant rate of change, so this is what the problem is going to have us look at. So it tells us in 2006, 500 million songs were legally downloaded from the internet. In 2004, 200 million songs were legally downloaded. We're supposed to use the data to graph the line that models the number of songs legally downloaded, y, as a function of time x. So time is always our independent variable, or our x. So it gives us, starting in 2004, so we could do maybe 2004, 2006, 2008, 2010, something like that. And then we have, that's our time. And then it says our songs downloaded is our y. So we'll set the songs downloaded up as y. And they told us that we downloaded 500 million songs in 2006 and 200 million in 2004. So that's going to, we need to start at least 200 million. Maybe go up by 2's. Something like that. And we're going to graph our 2 points that they gave us. So 2004 they said was 600 songs. Oops. Nope, 2004 was 200 songs. Oops. So we're going to graph 2004 at 200. And then 2006 there were 500. So that's going to be our next point. So that means we went up 300 songs and we went over 2 years. So if we continue that, that would be up 300 from that. That's going to be 900 over 2 years. And we can keep going, but that's going to give us our line. Then we need to find the slope of the line. So we're going to use our 2 points that we got here. Usually when we use years, we start with 0 as our starting year. So we're going to use 2004 as 0, and then 2006 will be 2. So our points that were used to find our slope is 0, 200, and 2, 600. And we're going to subtract the y's over the x's. To get negative 400 over negative 2 or positive 200. And that would be our slope. What that means is the number of songs downloaded legally increased by about 200 songs per year. And then the last part is, if this trend continues at the same rate, how many songs will be legally downloaded in 2020? Well, in 2006, or every 2 years, it's going up by 300 million. So if we go back to our graph, we got up to 2008 and we were at 900. So 2010 would be 1200, 2012 would be 1500, 2014 would be 1800, 2016 would be 2100, 2018 would be 2400, and 2020 would be 2700. So you would say about 2700 million songs. And then the next problem is going to have us find the slopes and then tell whether the lines are parallel, perpendicular, or neither. Slopes of parallel lines are the same. Slopes of perpendicular lines are called opposite reciprocals, so they're the opposite sign and they're the reciprocal of the number. And then neither would be either not the same or not opposite reciprocals. So we're going to have to find AB's slope and CD's slope and compare them. So AB, we have 13 minus 0 and 14 minus negative 11. That gives us 13 over 25. And then if we do that for CD, we have 7 minus negative 5 over negative 4 minus negative 3. So that gives us 12 over negative 1. So that would make it neither, because they are not opposite reciprocals and they are definitely not the same. And the next one, we're finding our slope AB, so 6 minus 2 over 3 minus negative 9 gives us 4 over 12, which we can simplify to 1/3. And then CD's is going to be 4 minus 3 over 5 minus 2, which gives us 1/3. So since they are the same, we would say these lines are parallel. The last problem, the lines were neither. Now, the last problem here, we're supposed to graph the line that contains 0, 1, but is also perpendicular to QR. So I'm going to graph QR first. -6, -2, and 0, -6. So that gives us a point here for Q, and R is here. Now, I would find the slope of QR first, because if we need to know that it's perpendicular, we're going to have to do the opposite reciprocal. So -2 minus -6 over negative 6 minus 0 gives us 4 over negative 6, which simplifies to negative 2/3. So our slope of our other line needs to be positive 3/2. And we are given 1 point on that other line, which is 0, 1. And that would be right here. So if we use our slope that we have to do the opposite reciprocal of negative 2/3, that means positive 3 over 2. So from 0, 1, we go up 3 over 2. And we would have our perpendicular line to QR. And that concludes lesson 3.3.